You know, it's tough out here on these streets. I don't have 2 pennies to rub in between my fingers, nor a scuffed YouTube loading animation to watch in my spare time, but we are going to solve one of these issues today, and it's not the money. Indeed, I'm going to show you how to make a procedural loading animation. It's kind of like a weird version where the circles scale down instead of become transparent, but what remains true is this thing is entirely procedural. We can say how many circles we want in this animation, kind of the size of the overall ring, as well as kind of like the maximum size these circles can grow to. Entire thing procedural and entire thing allegedly beginner friendly. I'm gonna try my best, but you know, these tutorials tend to have a lot of math, so we'll try our best. Basic Blender scene 2.92 alpha, I believe, using Eevee. Not even a camera pointing down, just a plane. And you know what? Really, that's all we need with a procedural material. So make a plane, be in Eevee, be in rendered mode, and let's get started. The way we tend to start these node groups is always with a texture coordinates node, just so we have XY data of the vectors or locations of the points all over this plane, right? And the name of the game is to make a radial array of circles, right? And we'll get to that in a second, but just the idea of a basic circle, just so we're all on the same page here. We take texture coordinates, we take length, and then we throw it through some kind of processing like greater than or something. And this is the basic setup for a circle. In other words, what we need to do is somehow repeat this in a way that we don't kind of reference a single origin point, right? So we only have a single black 0, 0 origin. We somehow need to generate more of these points going along a arbitrary, number of angles here. That's the game plan, and it actually turns out to be pretty simple. So since we want the angle, since we're using a radial array, probably makes sense to make a radial gradient. To do this, in the past we've done it with some math nodes, but I kind of forgot the gradient texture even existed. So take this, set it to radial, boom, we now have a radial gradient going from angle 0 around all the way to 1. Now, of course, this isn't really standard. Usually you have angle 0 over here in your high school trigonometry class, and it doesn't really matter, but just to keep convention strong and alive, or well and alive, I don't know how that phrase goes. Vector math, we're going to set this to multiply, and x and y multiply by -1. That just basically flips it. If we had this set to 1, it wouldn't flip it, but we need to flip it here and also on the other ones. Now we go from 0 all the way to 1. Okay. Also, if you remember from trigonometry class, typically we're talking about either degrees or radians as we go around here, not just a number between 0 and 1. I'm going to go with radians, but you could do whatever you want. So I'm going to take this gradient, multiply it, not greater than, multiply it by 2 times pi. By the way, you can just type in expressions right there and it will do it. So gradient from 0 to 2 pi. Okay, now what we want to do is kind of discretize or separate this gradient into a bunch of angles that we can talk about later, right? So we don't want this continuum, this gradient. We just want a set number of angles, like 5 or 4 equidistant from each other, okay? This is what the snap function is great at. So if we set this to snap, you can see it's going to round down to the nearest whatever, although we do want to be precise with this number. We want to round to the nearest, well, it can be something like 2 pi divided by 5. So we want to divide it into, let's say, 5 equal parts. It would look something like this. And if you're only seeing like black and white everywhere else, make sure this is set to filmic so you can actually see past 1, kind of like supervision. So yeah, what's happening here is we've taken this angle gradient in some sense and divided it into 5 equal portions, or 3 equal portions, or 15 equal portions, okay? That's the core idea here. And we want to turn this into a vector, not just kind of like a black and white map, a vector that we can actually talk about and compare to, okay? So hopefully you're following so far. We're taking combine x, y, z. We're going to take this angle information from here, and for the x and y, all we need to do is to go from angles back to like Cartesian rectangular coordinates, is we just process this through some sines and cosines, okay? So cosine here, duplicate sine for the y-axis, or you could flip it. Doesn't matter too much. So now we get kind of a radial thing that has sines and cosines in it, and then the final step, and of course I'm going to go back and explain this in more detail. The final step is we take this processed kind of vector we've created, calculate the distance, in other words, how far away the points are, the distance between that and the original object coordinate system. So let's see what that gives us. Okay. So you can see we definitely have a start here. What we're aiming to do, again, is to make a bunch of kind of like origins that we can create circular gradients out of, depending on the number of sections we want to take. Tiny correction term, since clearly these are kind of on the dividing lines, since the angle was snapped or rounded to here instead of like halfway across. So tiny correction, all we need to do to get these into center is before we send them through the sines and cosines, we take this and then we add. And you might be thinking, oh, we just kind of slide this until it's right in the middle. You could, but then if you change the number, it's not going to be accurate anymore. Turns out all you need to do is have it go halfway across this section, right? So all we need to do is add this quantity we calculated that's dependent on the number. Take it, divide it by 2, plug it in here. Okay, so now we can have 3 or 6 or 8 or whatever, you know? So we take this and same step as the last time, just, there's a couple more nodes beforehand this time. We take this, we set it to greater than or less than, and now we have a bunch of circles. A bit more control that we could add is how close are these circles to the actual origin of the plane. Well, again, this vector stores all our points. Take this, set it to, I don't know, either multiply or scale. Probably scale is a better way to think about it. Boom, or boom. It's not working. Got to connect these. It really does not like that. It's glitching out. There we go. We scale it so we can actually control how far away these vectors are from the origin. So we're just scaling them towards the actual plane origin over here. So again, what do we have so far? Right now, what we have is object coordinates that we turned into a radial gradient. We multiplied it by 2 pi, so it goes from not 0 to 1, but 0 to 2 pi. We then did snapping to an arbitrary number of sections, did a bit of a correction term, sines and cosines to get these vectors back, and then calculated the distance, made it a thing, okay? So far, long story short, what can we control? We can control the number of circles, we can control the distance away that these things are, and lastly, we can control the size of these circles. So now, really the last part of this to make it a loading animation is we just kind of animate the size of this for each circle individually is the idea. And it turns out it's actually pretty easy because we already have this radial texture. All we need to do is just kind of filter this and then do a bit of a multiplication. So color ramp, I don't like this discontinuity where it's going from black all the way to white. Instead, I want to remove this discontinuity. So instead, I'm going to make both of these black. In the middle, add in a white color. So now there's no discontinuity. It's going from black to white halfway across and then back to black, which kind of solves the issue. But one thing that isn't solved is if we take this and like add in a bunch of stuff to kind of animate this, we kind of run out of gradient. And of course, that's because we're going from 0 to 1, we're adding and then color ramping, right? So we could go above 1 hypothetically or under, which is the issue. So to fix that, take it, we want a round fraction, kind of removes everything that isn't the decimal, and now we have a rotating bad boy. Okay, cool. Take this, we are going to, I guess there's a couple ways we could think about this. Maybe the easiest is you could just take math, multiply, so we're taking our color ramp, again, this is the radial or spinning kind of sonar kind of situation. You take this, you multiply it by a certain number, and then you plug it in here. Okay, where this number is going to be kind of like the maximum size in some sense. So that when we animate this, you can see it's kind of doing that. If you don't want to keyframe that, this, by the way, quick trick, hash is a way to make a driver. Hash frame is going to take our frame number and automatically output it. Now, of course, it's not going to look like it's animating anything, mainly because, again, this is all kind of like modulo 1. So what we need to do is just kind of divide it by 30, make it go 30 times slower. And then you can see we actually have a interesting looking thing going on. If you're seeing a lot of distortion, by the way, there's a lot of ways to solve this, either with the, what's this called? Either the interpolation type or whatever, but kind of the easiest way to think about it is if we add in more circles, so let's say something like 15, make them smaller on average and also closer together. That distortion is going to be minimized because it's going to be hard to see when the areas of the circles when they're maxed out are so small. But I mean, I guess that's generally the node setup. I know this is kind of more, in some sense, difficult than usual. But really, all the idea is it's kind of like taking a circle and saying, don't just make it off the origin, make it off of a radial set of points that we, again, define mathematically, and then we just kind of control it. So there you go, loading animations, they exist. I hope you enjoyed this tutorial. And by the way, I only mentioned this at the end so it doesn't interrupt the flow. The tutorial Patreon exists. This is one of those tutorials that maybe you want the blend file for. That's going to be uploaded on Patreon, of course, and all other blend files I've ever uploaded are going to be available for you to download. Exclusive tutorials I do not upload on either channel are posted on Patreon, so not CG Matter, Default Cube, behind the scenes access, early access, like for example this video, probably going to upload it a day early for the patrons and stuff like that. I think there's probably a couple things I didn't mention, but Patreon exists. Get it if you want it. You don't need to if you don't want to. These tutorials are here for free. I hope you liked it. Thank you to all 550, 60 some active patrons. You guys are keeping the show running, and that's it. That's the tutorial. See ya.